Hey guys, Atam this side और आज हम सॉल्व करने वाले हैं आज का LeetCode question which is question number 279 perfect square. So before knowing the question, before reading the question, you should know what is a perfect square. So a perfect square is a number who has a square root which is a perfect integer, right? Which is a perfect integer, right? For example, square root of 9 is 3, which is a perfect integer, so 9 is a perfect square. Square root of 2 is 1.414, which is not a perfect, which is not an integer, perfect integer, so it is 2 is not perfect square. 25, square root of 25 is 5, which is a perfect integer, so 25 is a perfect square. Square root of 9, I've already talked about it. Square root of 16, which is 4, which is perfect integer, so 16 is also a perfect square, right? So let's read the question, what the question says. Just a second. Yeah, let's see the question. You are given an integer n and you have to return the least number of perfect square that would sum up to that number. For example, if you're given a number n, you have to find perfect square from 1 क्योंकि least perfect square तो क्या होगा, 1 ही रहेगा ना. Square root of 1 is 1, which is in perfect integer, so 1 is a perfect square, so 1 would be the least perfect square number. So you have to find numbers from 1 up to that number which are perfect squares and which would sum up to that number. For example, look at this example to understand. Your number is 12, so you would find 1 to 12 all the perfect square combinations, all the perfect square number combinations that would give sum 12, but not all, not you have don't have to find total number of combinations. You just have to find one particular way which requires least number of perfect squares that would give my sum up to n. For example, one case would be you can take 1 12 times, right? You can take 1 12 times and you would get a sum 12, right? So that would be requiring 12 perfect square numbers which are 12 ones, which is 12 perfect square numbers. So in this combination, taking ones only, you would require 12 numbers. So that is the maximum answer you can get. But what you have to do, you have to return the least number of perfect square you would be requiring. So you have to consider all the combinations, right? What you can do is you can hit and try. Obviously by going by brute force, you would hit and try. You can you will have to take multiple loops, or you will create a logic which is taking huge time complexity, right? Huge time complexity. So we have to consider possibilities in it, right? We have to consider possibilities. For example, you can take 1, then you can take 4, right? Then you can take 9, and then you can take 16. But you can't take 16, right? You can't take 16. You have to just maximum value could be 12, right? Maximum value could be 12. I told you you can go up to that number. 16 is greater than this number, which means that you cannot take 16, because 16 would itself return a greater value than the actual number, right? So what you will do is you will have to consider all the possible possibilities, right? What can be the possibilities? Let's understand the approach. What can be the possibilities? You can take 1 12 times, right? You can take 1 12 times. That's one possibility. What you can do, you can take 1, then you can take any number which is a perfect square other than 1, which means you can take 4, either you can take 9, or what can be the perfect square number lesser than 12? Only these three. Next would be 16, right? Next would be 16 perfect, which is a perfect square. You won't consider 16. So these three only you can consider, right? So let's consider all the possibilities. Once you have, first possibility was you have taken 1 12 times, which is requiring 12 ways, correct? Second would be you take 1, you take 4, which is giving 9. No, that is not the answer, because once one more 4 you would take, it would be greater than 12 itself. No, that would not be the answer. You can take 1 4 9, which would give us 14, which is greater than 12. That would not be the answer, right? What other possibility you can take is you can take 4 3 times, which would give us 12. And this is our answer. In this case, which means you just have to take three perfect square numbers, which is a minimum possible combination of perfect square numbers that would actually sum up to 12, which is the given number, right? So how would you build up this approach of possibilities, that you have to consider all the possibilities? You found the range. First step was finding range, right? Finding range of from where to where you would consider the perfect square numbers. So from 1 to that number you would consider perfect square number, right? मतलब square उनका perfect square numbers should be less than n, right? For example, 1 4, 9. These are the perfect square number and these should be less than n. Only then you would consider those perfect square numbers. Otherwise you won't take it, right? You won't take it. बड़ा नंबर आप क्यों लोगे 9 से? 9 से बड़े नंबर को सम करके थोड़ी उससे छोटा नंबर आ जाएगा, right? So understand this, understand this. You found the range. First step was finding range, right? Second step would be considering all the possibilities, all the combination of that particular of the numbers that come in that range that are perfect square. You have to consider all the possibilities, right? And considering all the possibilities require what? You know that wherever we have to consider possibilities, we will use recursion. If we use recursion, we have to find some base case, right? We have to find some what? Base case. Yes, we have to find a base case. Let's understand how would recursion work. Then we would go on to finding base case, right? Let's understand. let's say you found that for so what you will do is you'll iterate a loop till keep checking, you'll keep checking from one up to that number, but you don't have to iterate i's loop. You have to check whether the perfect square of I, let me just complete this loop. I plus plus would be at the end. You have to check whether the perfect square of I is less than n, which means when I is 1 less than n. When I is 2, you don't have to check 2. What you will check? Perfect square. What would be the perfect square in case of I is equals to 2? Perfect square would be 4, right? I into I would be the perfect square only, right? So 4 less than n check karenge. Then what you'll do for I3, you would check 9 less than n, and you will consider these numbers. So आप क्या करेंगे in questions में, when you have to find the sum, when the question says you have to find the number of combination that sum up to some number, you just find the approach of deducting that number, considering that number, deducting it from the sum in recursion approach, right? For example, what we'll do is we'll deduct the perfect square of from that number which is given to us, and we'll say that we have considered this number. For example, I 12 था, नंबर 12 था आपका. आपने क्या करा? I को 1 के लिए चलाया. तो आपने क्या करा? I1 पे चेक हुआ सबसे पहले कंडीशन की लूप चल भी सकता है या नहीं, which means 1 into 1 should be less than equal to 12, right? अब है ये तो ट्रू है, तो आपने क्या करा? फर्दर कॉल कर दिया, 1 प्लस कर दिया. 1 प्लस क्यों करा? क्योंकि ये आपने एक 1 तो कंसीडर कर लिया ना, आई की एक वैल्यू तो कंसीडर कर, मतलब एक तो परफेक्ट स्क्वायर आपको मिल गया ना जो आप रख रहे हो, और बाकी आप सब कैटेगरी बांट दे रहे हो आगे वाले फंक्शन के लिए, उसको छोटा कर दे रहे हो. which means अब मुझे कॉल करनी होगी, अगर मैंने एक कंसीडर कर लिया तो अब F11 के लिए कॉल करनी होगी. क्यों? 12 minus 1 is 11. बचे हुए 11 के लिए कॉल करनी होगी ना, सेम फंक्शन. So that is why we are increasing 1. For example, let's say I1 ना होता, I2 होता, right? I2 होता. So condition would be 2 into 2 less than 12, which means 4 less than 12, right? Which is between 4 less than 12. So you would also consider 4. So आप क्या करेंगे? आप यहाँ 4 ऐड नहीं करेंगे, you will only add 1, because आपको number of perfect square ढूंढने हैं. तो आपको एक और perfect square मिल गया which you are considering for now. तो आपको एक मिल गया, and what you will call, on what value you would call the function again? 12 original value, 12 minus 4, right? You have taken out 4 ना, you have taken out 4 from 12, which would return 8. क्यों? 8 बचे हुए 8 के लिए आपने फंक्शन कॉल करना है. Why? Because you have already considered a perfect square number which is 4. 4 कंसीडर कर लिया 12 में, तो बचे हुए 8 के लिए तो कॉल होगा. सो अंडरस्टैंड दिस, दैट्स व्हाई वी आर एडिंग 1, क्योंकि हम एक परफेक्ट स्क्वायर नंबर तो कंसीडर करके चल ही रहे हैं ना, राइट? What we'll do is let's understand the function definition now. Let's understand the function definition quickly. What you will do is, you know that you have to iterate a loop from I1 to that number, right, to that number, but the condition you're checking is you have to check whether the perfect square of I is less than or not, because perfect square तो consider करने, right? Perfect square तो consider करने, correct? Then what you'll do is you will say that answer, just increase 1 in yourself and call for rest of the part would be sum, which is your number actually, let's say I'm calling for this whole function for f of sum, this whole function. So sum माइनस कर दो वाला परफेक्ट स्क्वायर जो मैंने ऑलरेडी कंसीडर कर लिया है, और उसको कंसीडर कर रहे हो तो हमें वेज काउंट करने हैं, हम नंबर काउंट करने हैं ना, तो एक तो इंक्रीज कर दो कि एक परफेक्ट स्क्वायर तो अपन को मिल ही गया है ना, राइट? और बाकी बचे हुए सम में से डिडक्ट करो उस परफेक्ट स्क्वायर को, और बाकी बचे के लिए कॉल कर दो, राइट? अब आप सवाल करेंगे, अब आप क्वेश्चन, यू शुड क्वेश्चन दैट हमें तो मिनिमम फाइंड करना है, दिस वुड फाइंड ऑल द पॉसिबल वेज. right? All the possible ways by which we can find that number. अब आपको बेस केस समझना होगा, बेस केस समझना होगा, एंड यू हैव टू अंडरस्टैंड मिनिमम कैसे निकालेंगे, right? Base case would be you can also go by when sum becomes zero, you have found a number, you have found a combination, you can say that, but what we'll do is we'll do smart work. What smart work we'll do, हमें पता है परफेक्ट स्क्वायर नंबर्स, मान लीजिए नंबर आपका ओरिजिनल नंबर जो इनपुट है वो 1 2 3 है, तो 1 के लिए कितने परफेक्ट स्क्वायर नंबर आप सम करके 1 बना सकते हैं, एक ओनली 1 विच इज 1। 2 के लिए कितने परफेक्ट स्क्वायर रिक्वायर्ड होंगे, 1 विच इज ओनली 2, क्योंकि 2 से छोटा कोई परफेक्ट स्क्वायर है ही नहीं। 3 के लिए कितने नंबर्स रिक्वायर्ड होंगे, ओनली 1 विच इज 3 ओनली, क्योंकि 3 से कोई छोटा परफेक्ट, आई एम सॉरी 3 के लिए, आई एम सॉरी 2 के लिए कितने परफेक्ट स्क्वायर नंबर्स रिक्वायर्ड होंगे, 2 which is 1 plus 1, which are the only perfect square lesser than 2। 3 के लिए कितने perfect square required होंगे, 3, which are 1 plus 1 plus 1, because 3 से छोटा कोई भी perfect square number नहीं है, right? कोई भी perfect square number नहीं है। और अदर आपका बेस केस क्या हो सकता है, फॉर एग्जाम्पल अदर बेस केस क्या हो सकता है, ये तो फर्स्ट बेस केस हो गया। फर्स्ट बेस केस क्या हो गया कि भाई इफ आपका नंबर इज लेस देन इक्वल टू 3, लेस देन इक्वल टू 3, तो जो आपका नंबर होगा वही रिटर्न कर दो, यानी लेस देन इक्वल टू 3। 3 के लिए 3 केस लगेंगे, 3 नंबर्स लगेंगे परफेक्ट स्क्वायर। 2 के लिए 2 परफेक्ट स्क्वायर नंबर लगेंगे विच इज 1 प्लस 1। 1 के लिए एक परफेक्ट स्क्वायर नंबर लगेगा विच इज 1। तो n के लिए लेस देन 3 है, जब लेस इक्वल टू 3 है तो n ही लग रहे हैं, 3 के लिए 3, 2 के लिए 2, 1 के लिए 1। सो दिस इज वन बेस केस, राइट? लिख लेते हैं इसे अच्छे से, दिस इज वन बेस केस। बेस केस क्या हो गया, n लेस देन इक्वल्स टू 3। Second base case, what would be the second base case? If your number is a perfect square, what you can say, if your number is a perfect square, which means मान लीजिए आपका नंबर ही perfect square हो गया, मान लीजिए 25 था आपका नंबर, कहीं आइटरेशन करके सम डिडक्ट हो गए 25 आ गया, so you can say that it is a perfect square। तो भाई इसको अगर मैं 5 का स्क्वायर कर दूं, so this right, अगर मैं 5 का स्क्वायर कर दूं, अगर मैं what I can say is अगर मेरा 25, अगर if I ever got a perfect square, then I would just return 1। क्यों? Then I could actually take that perfect square only, right? That perfect square only। For example, sum की कुछ वैल्यू थी और एक फंक्शन कॉल में डिडक्ट होके किसी पॉसिबिलिटी में सम की वैल्यू हो गई 25, राइट? विच इज अ परफेक्ट स्क्वायर, राइट? विच इज अ परफेक्ट स्क्वायर। सो आई कैन से भाई तुम रिटर्न कर दो ओनली 1, क्योंकि यहां तो एक ही केस है ना। आई कैन टेक फॉर फॉर्मिंग 25, व्हाट इज द मिनिमम नंबर ऑफ परफेक्ट स्क्वायर आई वुड रिक्वायर, 25, which is itself a perfect square, only one, right? Which means only one, I would require only a number, only a perfect square which is 25 to form sum up to 25। समझिए आप, फॉर एग्जाम्पल 16 आपके पास था विच इज अ परफेक्ट स्क्वायर, तो आपको 16 बनाने के लिए कितने परफेक्ट स्क्वायर रिक्वायर्ड होंगे मिनिमम नंबर में, ओनली 1 विच इज 16। आप डायरेक्टली ले लेंगे ना परफेक्ट स्क्वायर, सो दैट वुड बी द बेस केस ऑफ परफेक्ट स्क्वायर दैट यू कैन एक्चुअली फॉर्म। बट what we'll be working with is we'll working with only the base case of n, right? We'll only use the base case n less than equals to 3, right? That would be the base case, that return n, and why return n I have already explained. This would be the base case, right? This would be the base case. Now let's code up this crappy logic and let's put it into a single code, how this would look, right? Let's see the code. This is the code, and this was the original function you were given in that question, which actually gives you a number n. What I had done is I had just passed this number into the fun function, right? And I have taken it as sum. This is the base case. If sum less than 3, less than equals to 3, return sum, right? If sum is less than equals to 0, return int max. And why int max? Understand this. Why int max? We have considered answer, we have taken answer in which we are actually finding the number of perfect square as int max, because we have to consider minimum। अगर मैं इनिशियली उसे इंट मैक्स कर लेता हूं तो फर्स्ट केस के लिए वो तो कंसीडर होगा ही नहीं ना, ये फर्स्ट केस के लिए इंट मैक्स वैल्यू है एंड वी हैव टू फाइंड मिनिमम। सो कुछ भी नंबर यहां आएगा वो तो इंट मैक्स से तो छोटा ही होगा, सो विल गेट फॉर फर्स्ट आइटरेशन आंसर विद समथिंग, नॉट गार्बेज वैल्यू, नॉट इंट मैक्स, राइट? सो इसलिए हमने मिनिमम निकालने के लिए आंसर को इंट मैक्स ले लिया है एंड वी हैव टू फाइंड मिनिमम ऑफ आंसर and 1 plus sum of rest, fun of rest, right? Rest of the, वो अब रेस्ट बताया था मैंने कैसे निकालते हैं वो, right? So we have to find minimum of both and store it in the answer, right? And we have to finally return the answer. So this is the approach। अब बेस केस समझिए, अगर sum less than 0 हो गया, अगर सम डिडक्ट हो के परफेक्ट स्क्वायर लेस देन 0 हो गया, विच मीन्स मान लीजिए ओरिजिनल नंबर 16 था, अब आपके पास सम हो गया -3, तो आपको कह देना है कि भाई जो भी तुमने कॉम्बिनेशन चुना है, जो भी तुमने कॉम्बिनेशन सुना है, तो वो गलत है, वो कॉम्बिनेशन नहीं चुनना। नहीं चुनने का मतलब क्या हुआ कि उसमें रिटर्न कर दो इंट मैक्स। फॉर एग्जांपल अगर यहाँ इंट मैक्स रिटर्न हो जाता है और आंसर इज लेसर देन इंट मैक्स विच मींस समथिंग लाइक 14 12, सो डोंट कंसीडर दिस पॉसिबिलिटी, just keep your answer as it is, don't update it with another value which is greater। तभी तो हमने मिनिमम लिया है। सो हम क्या कर देंगे ऐसे केस में, जब हमें वाली पॉसिबिलिटी वाला कॉम्बिनेशन ऑफ परफेक्ट्स को कंसीडर नहीं करना है, दैट विल जस्ट रिटर्न इंट मैक्स, कि भाई वाली कंसीडर ही मत करो। Automatically when you will return int max, it won't be considered that possibility which is returning negative sum won't be considered, right? So this is our second base case which we'll consider. So right, this is our recursion approach. What we are doing in this, let's first take an example and solve it, right? Take an example and solve it. For example, you have taken number 13, right? So f of 13 would be the initial call, which would be made by the main given function. This is the function we have made now. This is the function which was originally present in the question. So f13 would be original call, right? Then what will happen? This loop would work because none of the case would match, right? None of the case would match. This loop would work. For I is equals to 1. For I is equals to 1, right? Then 1 plus, we have got what? 1 plus, right? Just a second. So this would call for 1 plus f of 12. Correct. And this would further call for I is goes to 1 iteration. अब हर iteration में, हर function call के लिए पूरा loop तो चलेगा ही ना, ये पूरा loop तो चलेगा ही, right? ये पूरा loop चलेगा, which means the perfect square only 1 plus f of 11 would be called, further 1 plus f10 चलता रहेगा and we would जब तक चलेगा जब तक इसकी वैल्यू 1 प्लस एफ ऑफ 3 नहीं होती। क्यों? एफ ऑफ 3 होते ही सम लेस देन इक्वल टू 3, ये वाली कंडीशन ट्रू हो जाएगी और सम ही रिटर्न कर दूंगा, विच मींस 3 रिटर्न कर दूंगा इस केस में, राइट? 3 रिटर्न कर दूंगा, विच मींस दिस होल फंक्शन कॉल फॉर आई इज गोस टू 1 1 1 1 1 सबके लिए वुड रिटर्न 12 और ये आंसर में स्टोर हो गया, फॉर एग्जांपल, ठीक है? फॉर एग्जांपल आंसर में स्टोर हो गया, राइट? देन एक और फंक्शन कॉल, अब हम आंसर की तरफ कैसे रहेंगे? आई एम नॉट शोइंग यू कंप्लीट रिकर्शन ट्री बिकॉज इट वुड बी वेरी लार्ज, so let's just consider minimum small cases. How are actual function call being made? For answer I is equals to 2, 2 into 2 less than is 13. Is it less than 13? Yes, it is less than 13, which means what? 4 is less than 13, which means it would say that I have considered perfect square number which is actually 4, 1 plus, right? Actually 4, and what I'll do, I'll made a further function call for 13 minus 4, which is what? 13 minus 4 is what? 13 minus 4 is 9, right? 9. What you can do is for further अब इसके लिए भी 1 से लेके 9 तक फंक्शन कॉल होंगी, राइट? इसके लिए 1 से अब सम चेंज हो गया ना, तो 1 लेस देन इक्वल्स टू आई इंटू आई, ये कंडीशन जब तक ट्रू है तब तक फंक्शन कॉल होगी। अब सम बस इस फंक्शन कॉल के लिए 9 हो गया है, तो 1 से लेके आई इंटू आई जब तक लेस इक्वल्स टू 9 है तब तक फंक्शन कॉल होगी। फॉर एग्जांपल यहाँ फिर से 2 के लिए कॉल होगी, या फिर से अब हम ले लेते हैं फिर से कि भाई 3 के लिए कॉल होगी, which means अब कंडीशन चेक होगी 3 into 3 greater than equals to 9. Yes, it is true. Then what it'll do, it will just made a further function call 1 plus for 9 minus what? 9 minus that perfect square number which is I into I, right? तो ये क्या हो जाएगा? 0, right? ये हो जाएगा 0. Then what will happen? I have got 1 also. Then function call for 0 would be made. Function call of 0 would be made, and any function call you would made here would return negative, which would return int max. So I would consider only this one because minimum consider करना है ना. I would only consider this one. I wouldn't consider this whole function call, next function call which is returning min वो int max on, right? अब मैं इसके int max से और इस वाली वैल्यू में से which is this one is smaller, so I won't consider this because right this मैं क्या consider करूँगा? ये consider करूँगा, right? ये कंसीडर करूंगा विच इज 1 प्लस व्हाट रिटर्न करेगा ये 1 प्लस समथिंग, राइट? 1 प्लस समथिंग, 1 प्लस इंट मैक्स, तो आंसर अभी भी 1 है, यहाँ पर 1 प्लस और हुआ तो आंसर क्या हो गया? 2. सो यू हैव गॉट व्हाट? यू हैव गॉट two possible perfect square number which is 4 and 9, which is 4 and 9, which would sum up to 13, which is the minimum possible combinations of perfect square number, right? So this is our recursion code. Right? This is our recursion code. Let's quickly understand the time complexity of this code, and we'll minimize it using memoization, right? Now let's quickly see the time complexity of this approach, of this recursion approach. Then we'll go to the memoization part. So in this approach, what are the time consuming steps? Let's see. This is a base case, obviously no time consumed. Base case, no time consumed of 1. Right, this is a loop which runs how much time? कितने time you loop run करेगा? Square root of n times अगर सम n है, right? And each iteration is making a function call, further function call till what value it will take. अब सम में से हर बार किसी नंबर का स्क्वायर कम हो रहा है, which means it would make 2 to the power square root of n function calls, right? It would make 2 to the power n function calls, which means overall this loop would take what? N into 2 to the power root n function calls, which is exponential. So we can say that time complexity, overall worst case time complexity, would be 2 to the power n, which is the input number, right? So this is the time complexity. And what would be the space complexity? That would be only O of n, which is of recursion stack. So this is a huge time complexity. We don't want exponential. So what we'll do is we'll do memoization. Memoization में क्या होता है? DP बनाते हैं आप. So we'll make DP बना के पास कर दिया. और कब तक DP बनाएंगे? n+1 साइज की क्यों बनाते हैं? कब n+1 साइज की बनाते हैं? When we have to actually access the value of n, which we are passing in the original function, right? N pass कर रहे हैं ना, तो when we have to access this value n, right? For example, initially your n was 25. So you have to access 25 value. So you have to create a DP of 26 size. Then only you can get index up till 25. That's only when you can access this value and update this value in the DP, right? And obviously only one variable is changing, so we'll make DP of size one dimension only, n+1 and -1 इसलिए कर दिया, ठीक है? What we can do is other thing would be DP में क्या करते हैं? DP में we just check अगर वो वैल्यू पहले से अपडेटेड नहीं है, which means DP of sum is not equals to 1. हमने इनिशियलाइज करी थी DP -1 से. अगर DP -1 के वैल्यू बराबर नहीं है DP की वैल्यू उस पर्टिकुलर इंडेक्स सम पे, then what we can say, we have actually calculated this value and we don't have to calculate it again. So we'll just return that value DP of sum as it is to the function call, whoever made that function call to that function. And what we'll do is we'll store the answer in DP of sum, which is actually storing part, right? So this is our DP or memoization approach. What we'll do is let's calculate the time complexity of this approach. Again base cases, no time complexity consumed. This loop iterates how many times? Square root of n times, right? Square root of n times. And this is what? These are function calls, and no more further function call will be made. Only every number जितनी भी बारी रूट जितनी भी बार ये वैल्यू रहेगी, कितनी वैल्यूज रहेंगी टोटल? स्क्वायर रूट ऑफ n. तो जितनी बार ये जितनी हर वैल्यू पे एक बार आइटरेट करेगा, which means हर वैल्यू के लिए एक बार फंक्शन कॉल मेड होगी, which means ये वाला पूरा लूप would require only square root of n time complexity, which is less than 2 to the power n. We have reduced significantly the time complexity using what? Memoization. And again we have a space complexity would be of n only, because we are using what? We are using vector of DP, right? So there would be no that much big recursion stack. There would be only what? Another vector, which is DP, which would take of n time complexity. So this was our approach for today's question. If you haven't understood any part of this approach, do comment it and just mention it. I'll reply as soon as possible. And that's all for today. Coding करते रहिए. All the very best.